Let's work on 5.2 skill practice. First question. Supposing that we have a right triangle ABC, we want to find the 6 trigonometric functions for angle B, where angle B is the larger acute angle. And the larger angle is going to be opposite the larger side. So let's draw that triangle. In our drawing here, we have our right angle, we have our angle theta that represents angle B, and we have our side lengths. Now we need to find our missing hypotenuse when we do that using the Pythagorean theorem. And so our hypotenuse is going to be equal to the square root of 6 squared plus 3 squared. The square root of 45 has a perfect square inside of it, as it is the square root of 9 times the square root of 5, because 9 times 5 is 45, and the square root of 9 is 3. So I would write that as 3 root 5. Now remember, we're going to be rationalizing our denominators here. We don't want to have any square roots in the denominator. So let's start out with the sine of theta. That's opposite over hypotenuse. So opposite theta is 6, and over the hypotenuse, which is 3 root 5. We want to multiply by the square root of 5 over square root of 5 to rationalize that denominator. That gives us 6 root 5 over 3 times 5, as the square root of 5 times the square root of 5 is just 5. And notice that I can actually simplify 3 and 6. That becomes 2 root 5 over 5 for the sine. Cosine of theta, I'm going to use the same sort of idea, is adjacent, which is 3, over hypotenuse, which is 3 root 5. Rationalizing the denominator, we get 3 root 5 over 3 times 5. Those 3's can cancel, and I have root 5 over 5. And the square root of 5 over 5 does not become 1. You can't cancel inside the radical of 1 that's not inside the radical. The tangent is equal to opposite over adjacent, which is 6 over 3, or just 2. Now remember that the cosecant is the reciprocal, so we're going to be dealing with the cosecant of theta, which is hypotenuse over opposite. So hypotenuse is 3 root 5, opposite is 6. That simplifies to the square root of 5 over 2. It's easier to write it that way rather than trying to find the reciprocal once we've rationalized the denominator. The secant of theta is equal to the reciprocal of cosine, which is the hypotenuse over the adjacent side, which means we have 3 root 5 over 3, or just root 5. And then cotangent of theta is equal to the reciprocal of tangent, which was opposite over adjacent, so that is adjacent over opposite, or 3 over 6, which reduces to 1/2. Skill practice 2 gives us an actual angle measure and asks us to evaluate a different trigonometric function. So in this case, I like to draw triangles and label them based on the information. So it doesn't matter where you draw your angle theta as long as you put your values in the right place. Opposite of theta is 3, hypotenuse is 4, because sine is opposite over hypotenuse. So this is the opposite and this is the hypotenuse. Now, I need to find what the missing side is in order to be able to evaluate this question, because secant is the reciprocal of cosine, which involves adjacent. A equals the square root of 4 squared minus 3 squared, or 16 minus 9, which is 7. A is the square root of 7 then. The secant of theta is the reciprocal of cosine, which is adjacent over hypotenuse, so it's going to be hypotenuse over adjacent, which is 4 over root 7. We always rationalize that denominator, and we get 4 root 7 over 7. Skill practice 3, evaluating cosecant of 45, secant of 45, and cotangent of 45. Remember our 45, 45, 90 triangle. Cosecant of theta is equal to the hypotenuse over opposite as it's the reciprocal of sine. Secant of theta is hypotenuse over adjacent as it is the reciprocal of cosine. And cotangent of theta is adjacent over opposite. Cosecant of theta is root 2 over 1, which simplifies to just root 2. Secant of theta is root 2 over 1, or just root 2. And cotangent of theta is 1 over 1, or 1. And again, those are in that chart above that we worked on in the notes. And so if you have that chart handy, you start to memorize those values, they'll come very quickly too.